Okay, so first starting from year 2020, this is question number 7. Okay, first part, an electromagnet consists of a solenoid X that is made of copper wire. The solenoid contains an iron core. Explain why the structure of copper makes it a suitable material for the wire.
Copper is a metal and it's a good conductor.
Okay, copper is a good conductor. It is a metal. Structure of the copper. Any other suggestions? Electromagnet consists of a solenoid that is made up of copper wire. Okay.
About malleability,
Hmm. Because they are also asking about the structure of copper, that what is the difference in the structure of copper that make it more suitable to use in this whole setup. Okay. So to write the answer for this question, so copper is a good conductor. And when you are talking about conductor, always mention that conductor contains 3 electrons. It contains 3 electrons. That makes copper up. And the next part,
is it because it's a temporary magnet?
iron is a suitable material for core of an electromagnet. Yes, because we know that iron is not a permanent type magnet. It's a temporary type magnet. So we can use it like both during magnetism and demagnetization process. So you need to write 2 points. So the first one is iron can easily be magnetized and demagnetized. Okay. Next part is okay. In next question, there is a solenoid and it shows the setup of electromagnet inside a second solenoid Y. So describe and explain what happens in solenoid Y when X solenoid is connected to an alternating current power supply. So basically, this is solenoid X, and then we are using an other coil that is made up of these dark line. So basically, this wire is representing solenoid Y. So describe and explain what happens in solenoid Y when solenoid X is connected to an alternating current AC power supply. So X is connected with AC As you can see over here, it is connected over this point. So now we need to explain what happens in solenoid Y.
So alternating current is produced by solenoid X.
Hmm. Okay, because we know that when AC current flows through the solenoid X, so there will be change in direction of AC, right? And due to that change of direction of electric current, magnetic field will produce, right? And that changing magnetic field will produce, or that will induce EMF in the second coil, that is solenoid Y. So the same concept we need to write for electromagnetic induction. So answer is very simple to write. We just need to mention the basic concept of electromagnetism. So we can write it as when AC goes through the coil or solenoid X due to change in the direction of current, magnetic field lines also changes for the solenoid Y, and that change of flux in magnetic lines will induce EMF in the solenoid Y, right?
Yes.
Okay, part 2, a switch and a lamp are connected in series with the terminal of solenoid Y. When the switch is closed, the lamp lights up off at normal brightness. Describe and explain what happens to the current in solenoid X when the switch is closed. So basically, a switch and a lamp are connected in series with terminals of solenoid Y. So it means this is terminal Y, and we are going to connect a switch over here. Let's suppose like this. And then we are having a lamp, and this connection will complete over here. So this is like a series combination, right? And they are asking, describe and explain what happens to the current in solenoid X when the switch is closed. Okay, so now we are having an option that we can open or close this switch, which is placed over here. So when we close this switch, it means when we turn on the switch or turn on the button for the current which is going to pass through this lamp. So what will happen in solenoid X? Any idea?
The current will flow with greater power.
Yes. In solenoid X, it means the value of current will increase in solenoid X. So the first thing is current will increase in solenoid X because now it is going to supply the main power to that lamp, because we are going to generate electricity by the concept of electromagnetic induction. So it means that to light up that lamp, and when the switch is closed, the lamp lights up at normal brightness. So to maintain the brightness, we need to increase the current in solenoid X. So that's why lamp Y will, or sorry, the lamp which is connected with solenoid Y will continuously light up. It provides the power to the lamp connected with solenoid Y. Okay.
Yes.
Okay, so this is first question of this year, May June variant 1. Let's try the second one. This is variant 2, May June. Let's see. Okay, question number 7.
Sir,
Yes,
how do we calculate the number of packs?
number of
Number of packs in the power supply?
packs in the power supply.
Yes.
Actually, number of packs is not a type of such concept which is included. Maybe there is some special case in the question. It depends upon the situation of the question, that what the question is asking about. Maybe there is some information related to the packs, that this pack provides this amount of energy, just like the amount of cells and amount of battery we talk about. Let's suppose if we are using battery with our laptop, so the voltage, the power, the current of that battery is different from the normal cell or the normal battery. So basically, it's not a particular concept in the electricity. It depends upon the question, that maybe a question is designed in such a way that they are asking the question in different form.
Right, sir.
Okay, a student makes a transformer that uses an alternating current supply with an EMF of 12 volt to introduce an output potential difference of 2 volt. The student is provided with two lengths of insulated wire and the U shape. Okay. Complete and label figure 7.1 to show transformer connected to the supply and output from transformer. Okay, so you need to complete this diagram, plus show the transformer connected to the power supply and the output from the transformer. So you need to complete this whole diagram. So what will be the structure?
And there'll be two coils on both sides.
Yes, two coils on the both sides. Good. So let's suppose we are going to make two coils. First on the left hand side, and it is connected with a power supply. And always remember, uh, in transformer, coil is always connected with AC supply, right? Not DC. So when you are going to draw the power supply, so always draw for AC, no need to draw for DC. And for right hand side, we are having another coil, the secondary one, and we connected with a voltmeter because we are getting output over here. So to find the output voltage or the EMF, we connected with the voltmeter. And we need to mention this is primary coil and this is secondary coil. Okay. Explain the function of the piece of iron in the transformer.
To transfer magnetic field.
Yes. To transfer or to link magnetic field between primary and secondary coil. And one more thing we need to mention,
Efficiency?
yes, because it has higher efficiency. So better induction or efficiency will be greater. Okay. Third part, the output of the transformer is connected to a lamp. The current in the lamp is 100 milliampere. The transformer is 100% efficient. Calculate the input current to the transformer. So we need to calculate the input current to the transformer. And in the question, we are having some other values also. EMF supply with, okay. So we are having 12 volts connected with the primary coil, and the output is equals to 2 volt. Okay, it means we need to increase the number of turns in primary coil. So let's increase the number of turns. Yes, this will be fine. So now we are having 12 volt with the input and 2 volt with the output. So voltage with primary coil is equals to 12 and voltage with secondary coil is equals to 2. And the value of electric current, the current in the lamp is 100 milliampere. So this current is for input or output or primary or secondary.
This is output.
Yes, because this is connected with the lamp which is used for the output process. Okay, so this is IS 100 milliampere. So now what will be the formula to calculate the input current?
Will we divide the current by the voltage?
Yes. So we start like this. Whenever they ask that transformer is 100% efficient, so always remember two things. You just need to compare the power on both sides, that input power is equal to the output power, or we can say that the voltage we can compare with the reference. It depends upon the question. Most of the time they ask about number of turns. So we use the formula of number of turns. But if they are asking with the reference of voltage and current, so we know that in the uh, formula of power, there is a reference of value of voltage and current. So we write it as that the input power or the power in primary coil is equals to the primary power in secondary coil. So power is equals to primary voltage multiplied by primary current is equals to secondary voltage multiplied by secondary current. So just we need to multiply all these values. So VP is equals to 12, IP is equals to unknown, and 2 multiplied by 100 exponent minus 3. And now we just multiply these two quantities divided by 12, you will get the answer. So current will be equal to around 0.017 ampere. I hope you will get the same answer.
Yes, sir, I got the same answer.
Yes. Okay, so the last part, another transformer is used in a school laboratory to step down a main supply with a potential difference of 110 volts to 12 volt. So now we are going to make a step down transformer because we need to step down a high voltage to a very low voltage. And this case, this transformer is mounted in a metal case. Okay. State and explain an essential safety feature required for this arrangement.
Earthing?
Mm, can you repeat again?
Earthing? The metal case can
Earthing.
be earthen?
Yes, very good. So we need to earth this metal case. The first safety precaution we already studied in the chapter of practical electricity. So this is most important concept. because we are going to generate induced EMF. So this metal cases need to be earthed over there. Any other? Because question is for 2 mark.
A fuse?
Fuse is not required in this concept because wire is not going to melt. Insulation, you just need to remember all the safety precaution we studied, because now we are not going to uh, work like there are different components and we need to save the components. So the next option is the insulation process must be, so we need to check out the insulations. Okay, so these are two safety precautions which is important for us, right?
Yes.
Okay. Okay, so this is the second variant. LED. I think in our previous variant, we also have some other questions related to electricity. Okay, so this is the concept. Calculate the number of packs in power supply.
Yes.
Okay, so let's solve this one. The power supply used in an electric vehicle contains 990 rechargeable cells, each of electromotive force of 12 volt. Okay, so we are using 990 rechargeable cells, each is 1.2 volt, right? And the cells are contained in pack, in which all of the cells are in series with each other. So now this is a particular concept which is not included in your theoretical concept, you can say that. So that is a special case which is just designed for this question. So basically the cells are contained in a pack with which all cells are connected in series with each other. Okay, so now we are having a pack of cells connected in series. And why we are using uh, cells in series? Because we know that in series combination the EMF of the cells are going to be combined, right? Okay, so the EMF of each pack is 54 volt. So we are going to make a packs, and for each pack, so this is like a batteries. Let's suppose we are going to design a battery, and we design a battery in which there are, or which we can say that it will provide the output of 54 volt, right? We use multiple cells and we combine all the cells and make a battery, just like the power banks, right? You know that power banks are of different range, so that are made up of batteries, different combination. So either we can make it with a simple or single battery, or we can also make it with multiple rechargeable cells, right? We combine all them in series or in parallel combination according to our requirement. So that is the basic concept or the question they are talking about, that we combine multiple cells and made a packets, right? And the EMF of each pack is 54 volt, right?
Sir, could our answer be 22?
Answer will be 22. Yes, your answer will be equal to 22 because we are having total 990 rechargeable cells, right?
Yes.
And we need to make a pack which is of equal to 54 volts, right? So you just need to divide. So we are having total 54 volt and each cell is made up of 1.2 volt, right? So 54 divided by 1.2, we will get 45. So it means single pack contains 45 cells, right? 45 cells in a single pack. And if we need to find out the total number of packs, so for total number of packs, 990 divided by 45, so you will get 22 number of packs, right?
Yes.
Okay, when in use, each pack supplies a current of 3.5 ampere. Okay, so each pack is supplying a current of 3.5 ampere. Calculate the rate at which each cell is transferring chemical energy to electrical energy. So we need to find out the rate at which each cell is transferring chemical energy to electrical energy. So basically they are talking about the concept of rate. So a rate is just like when we write the definition for the power. So basically power is a rate of doing work, right?
Yes.
So basically they are talking about the concept of power. So if we need to calculate the power, so power will be equal to VI. So 3.5 is the ampere which we are getting from each pack of a battery. And what is the next value? And the voltage of each cell is 1.2, right? So the voltage of each cell is 1.2 and the current from each pack we are getting is 3.5 ampere because this
Sir, why won't we use 54 volts?
54.
Because that's the EMF of the pack.
Hmm. Actually, they are talking about the calculate the rate at which each cell. So they are talking about each cell, right?
Oh, right, sir.
So that's why we use the voltage of 1.2 for that single cell and then we multiply it with the value of electric current mentioned in the question, right? Because you know that why we use 3.5, I will give you the reason over here because I think you got confused that there are multiple cells in each pack and we are using the value of electric current. So always remember it is mentioned in the first part that all cells are connected in series combination. So always remember that in series combination, electric current will remain same for each cell, right?
Oh, right, sir.
So if the electric current is 3.5 ampere, so it means that it will remain same for each cell which is connected in series combination. So that's why we use 3.5 because that is the same value of electric current for a single cell which is connected in series combination. So that's why we just multiply 1.2 by 3.5. So that will give you the rate of energy transfer. I think that will
4.2?
be
Yes.
4.2 watts. Okay, the packs are connected in parallel to a supply. Now they are connected to a parallel. A large current to drive the electric vehicle Explain why it is necessary to use thick wires to carry this current. Because they mention,
Greater resistance.
yes. So we have to transfer large amount of current. So to avoid a high value of resistance, we use thick wires, right? So thick wires have a smaller resistance, and the second thing is less energy, less thermal energy loss, right? Because when charges pass easily, so there will be less loss of heat energy, and efficiency will increase. Okay, so these are some necessary condition for using thick wire, right?
Yes.
Okay, let's try the third variant of this here. Question number 7. Okay, now question number 7 is related to light. Question number 8 is related to electric field, and that is no more included in our concept because that is related to induction. Yes, question number 9. Figure 9.1 shows a simple direct current electric motor. The coil rotates about the axis. When there is a current in the coil is connected to the rest of the circuit by the brushes. On figure 9.1, draw a pair of arrows to show which way the coil rotates. Explain the direction you have chosen. Okay. So you need to mention a pair of arrows to show in which way the coil rotates. That is
From
the
north to south.
uh, for this rotation, you need to use the left hand rule, right? That we studied yesterday. That first you need to find out the direction of magnetic field. So magnetic field is moving from north to south like this, right? Okay. The second concept, you need to find out the direction of electric current, right? So you need to find out the direction of electric current. So electric current will always move from positive or negative.
Positive.
Yes. So if current starts moving from positive side, so it will be somewhere at this position. So it will pass from the left hand side. So from left hand side, current is moving into the page, right? Like this. It is going into the page because diagram is like a 3D diagram. So current is moving into the page, not in vertical upward downward position. And from the other side, current will circulate and come back from the right hand side. So current is moving out of the page from right hand side. So this is out of the page and this is into the page, right? So now we need to explain, oh, sorry, before that we need to draw two pair of arrows. So now we can easily identify the direction with the help of Fleming's left hand rule. So let's try Fleming's left hand rule. Magnetic field is now just remember the directions, right? Forgot this diagram that which is the actual direction of this diagram. Don't need to place your fingers accurately like this. You just need to focus on the exact direction. Magnetic field is on x-axis, right? It is moving from left to right. So we place our first finger in this direction like this, from left to right. Okay. So do it like that. Palm is facing your side and you open your just first finger, and current is moving from, sorry, magnetic field is moving from left to right. So finger is pointing towards your right side. Okay.
Yes.
Now open up the second finger. Keep it perpendicular, right? Always remember three of them are mutually perpendicular. So now when you open your second finger, so second finger is pointing towards you, right?
Yes.
So when the finger is pointing towards us, it means we are talking about right hand side, this side, because current is moving out of the page from right hand side. So first we are finding the direction of right hand side. Okay. So finger is pointing towards us like this on Z axis, let's say. And now open up the thumb. So which direction you are getting from the thumb?
Upward?
Upward direction. So it means that force will act in upward direction from right hand side. This is the direction of force. Now just rotate your hand like this, that the second finger is pointing towards your screen or in front of you. So you will get the direction of thumb rotated by 90 degrees or 180 degrees. So force will act in downward position from this side when current is moving into the page, right?
Yes.
Any confusion?
No.
Okay.
But sir, why did we flip the hand?
To identify the direction of force on left hand side, because on left hand side current is moving into the page, so the direction of second finger will change
Oh, right, sir.
because we are not able to rotate our finger in the opposite direction. So that's why we need to rotate our hand in the direction of electric current. So direction of thumb will automatically change. Any confusion?
No.
So this is for right hand side, and for left hand side, our orientation will be like this, that this first finger will remain same because magnetic field is uniform. There is no change in it. Only a change is that uh, second finger is pointing into the page and we are getting the direction of thumb in downward direction. This is the thumb direction, which represents as the direction of force. So that is the simple concept, right? Okay, now explain the direction you have chosen. So why we choose this upward and downward direction? Because now we need to explain actually the rotation. So if we consider from right hand side, so coil will rotate like this, and from left hand side coil will rotate like this direction, right? So this rotation is clockwise or anti-clockwise?
Anti-clockwise?
Anti-clockwise. So first of all, current is moving from the positive terminal by using left hand rule. Identify the direction of force and we need to explain the direction. So direction will be anti-clockwise. So coil will rotate in anti-clockwise direction. Okay.
Yes.
Okay. So on figure 9.1, draw an arrow to show the direction in which electrons flow through the coil. So now we need
Negative.
from negative. So that is the electron flow. The second part of the question, this one. So this is for the second part actually. Explain why the electron flow in the direction you have chosen in A part 2.
Due to the non-conventional.
Yes, this is non-conventional. And this actually happens when negative is going to be repelled by the negative side. So current starts from the negative end. So it is going to be from the negative connection of the battery, the electrons are going to be repelled. So current will start moving from left hand side, or sorry, from negative side. State any difference. Each of the following changes make the rotation of the coil in figure 9.1, changing the polarity of the power supply to that shown in 9.2. So now we change the terminals. You may see over here that positive is now on right hand side, but in initial condition we started from left hand side the positive terminal, right? So there is a change in the polarity. So they mention it clearly. Okay. So changing the polarity of the power supply that's shown in the figure. So state the difference. So what will be the difference? The first part they are asking, which is related to the difference.
The current.
Yes, they already mentioned that there will be a change in the direction of electric current. So you need to identify what will be the change in the rotation of the coil.
Oh, clockwise.
Yes, it will rotate clockwise, or we can just simply write it that a rotation will reverse, or it will be in opposite direction. So now coil will rotate in clockwise direction. Part 2. Changing the coil to a new coil shown in figure 9.3. So this is our original coil, and now we are using a new coil which have, we can say that, two number of turns in the whole coil. So what will be the change in the rotation? So if we increase the number of turns in the coil, so what will happen?
It will rotate faster.
Yes. Actually, they are asking factors that increase the induced EMF, or that induce or that will increase the rotation of the coil in indirect way. They are asking with the reference of diagram. Normally they ask theoretically. Third option, using a stronger magnetic field. Again, the same concept. Coil will rotate more faster, or turning effect will be greater, right? Okay. So these are the variants from 2020, May, June. Let's try October, November. October, November, variant 1, same year 2020. Question number starting from 7. Yes. A permanent magnet is made from only one material. Underline the material from which it is possible to make a permanent magnet. You just need to choose the material.
Steel.
Steel, confirm? Okay, so here
Yes.
is the steel. Steel is over here. Okay, so steel is used to make a permanent magnet because we already discussed the difference between iron and steel. So we know the concept that steel will act like a most powerful permanent magnet. And they are asking to underline, so let's underline it, not circle it. Okay, an electron source produce a narrow beam of electron that all travels at the same speed. So basically there is an electron source which is going to generate electron in downward direction like this. Electron source is placed in a vacuum and the beam of electron travels vertically downward. Figure 7.1 shows the beam of electrons before it passes between the north pole and the south pole of a magnet. Okay, it is going to pass through the magnetic poles. In the diagram, it is mentioned that it is going to enter. Okay. So describe what is meant by direction of a magnetic field. State the direction of magnetic field. So that is simple. What is the direction of magnetic field?
North to south.
North to south. And they are only asking for 1 mark. Describe what is meant by direction of a magnetic field and state the direction of magnetic field. So they are asking 2 questions for 1 mark only. So we just simply mention that magnetic field directs from north to south pole. Next part. Describe and explain what happens to the beam of electron in the magnetic field between the poles of the magnet. So when
It deflects towards the north terminal.
okay. So first of all, electron or the beam of electron will deflect. Electron beam deflects. Okay, the second change. You mentioned that it will deflect towards North Pole. Actually, this is electron, right? And when we are talking about electrons, so we know that we are talking about the negative charge. So we can say that charges are moving from the negative side. So we need to use the left-hand rule to find out the exact direction of deflection. Because magnetic field is mentioned over there, electron source will give you the direction of electric current. So then you can easily find out the direction of force which is going to be act on the electron beam, that will give you the direction of deflection also. So again, use the left hand rule, place your finger in the direction of magnetic field, place the second finger in the direction of current, and then you will get the direction of the force. So we are having magnetic field on x-axis and electric current on y-axis. So it means our force will be on z-axis, either into the page or either out of the page. So now let's suppose you need to place your first finger from north to south. We place our finger from north to south, that is from left to right. The second thing, we need to open up second finger, and what will be the direction of electric current?
Out of the page.
Actually, this is electron source, right? It is going to generate electron. Actually, we studied that current will always flow from positive to negative. So this is the positive side, and this is the negative side. So use the basic concept. Place your second finger in the direction of electric current, that is positive to negative. So that will reverse your direction into the page, right?
Is there the palm facing towards me or the screen?
Actually, palm facing will be current is actually moving in upward direction. Yes, palm is facing in vertically upward direction. You need to place your hand like this, that first finger is from left to right, and you need to open up second finger and rotate your hand like this, that your palm is facing towards the upward direction or towards the roof of your room. So that will be the direction of electric current, because current is going to move in upward direction, vertically upward. So your first finger is pointing towards right hand side, and second will be in upward direction.
Oh, right, sir.
So now you will get the direction of force. So force is acting into the page, right? Any conclusion?
No.
So they are asking question for 3 marks. So the second part is deflection into the page, and we find out by using left hand rule.
Sir, how do we know if it's into the page? Because the
Mhm.
finger is just upwards or downwards.
Okay, actually thumb gives you the direction of force. You place your first finger from left to right, second finger upward. So thumb is facing towards the screen in this direction. This is the direction of thumb. Are you getting the same direction?
No.
Okay. Again, try to identify the direction. First, place your left hand. Open up the first finger towards right hand side. Then open up the second finger just perpendicular it, and rotate your hand like this. Your palm is facing the roof side of your room. So palm is actually facing in upward direction, right? And now open up the thumb. So now what direction you are getting from your thumb?
It's pointing towards me.
It's pointing towards you. Your palm is actually facing downward or upward.
The palm is towards the ceiling.
Palm is towards ceiling. So why you are getting, are you using right or left hand?
Left.
Okay, so using left hand rule, I will share you how it is going to work. Or just make it simple. Just place your finger in the direction of electron, and we identify the opposite direction, because we know that current will always flow from positive to negative. So you may work it like this, that place your finger in the direction of magnetic field and choose the downward direction. So that will be very simple, and then reverse the direction like this. I'm sharing the picture. So just select the direction from negative and then reverse the deflection. Okay, the picture I share with you is the direction of electron flow, right? This is for the electron flow, just like the same that electron is moving between the magnetic field, right? So
Right, sir.
basically thumb is pointing towards your side. And if you rotate the hand, so your orientation will be changed and palm is facing towards the ceiling. So that will be some different. Or just you find out the direction from the negative side and then reverse the concept, because you know that current will always flow from the positive side. So if we are getting out of the page when current is moving downward from the negative side, so it means when current moves from the positive side, we will get the direction into the page, right?
Right, sir.
Any confusion?
No.
Because sometime it will be difficult to rotate our hand in the direction, because this is not our regular practice. So you may continue with the same negative direction, then reverse the deflection, because current will flow from the positive side. A beam consists of alpha, beta, gamma particles, rays. Explain how a uniform magnetic field may be used to separate the alpha, beta, and gamma rays. Actually, this is most related to the nuclear section, because we know that beta will deflect with
Positive?
towards positive, but we are only talking about uniform magnetic field. So alpha and beta both deflects in opposite direction, right?
Right.
So alpha and beta will deflect in opposite direction. So there are three rays. So it means the two rays can easily be identified by alpha and beta, because they already deflects in opposite direction. And the second thing is, if we need to identify the gamma, so gamma can also easily identify,
There's no deflection?
no deflection. And we know that the deflection of beta is greater than alpha. So that is the concept also. So this is the answer of this question, right?
Yes.